This lecture covers section 7.2.3. At the end of this lecture, you should be able to analyze stresses using the method of sections. Similar to the method of joints, the method of sections starts by constructing a global free body diagram to determine the reactionary forces of the truss structure. For instance, if we revisit the truss structure from the previous lecture, we can determine the reactionary forces RAY and RAX at pin A and RIY at a roller support. Then we'll make imaginary cuts to the truss members to solve for the internal reactionary forces in each member. When we make the cuts, we express the internal reactionary forces of the members as acting outward from the cut, i.e., they follow the unit normal. Each cut represents an unknown, and we can only have 3 unknowns at a time since we only have 3 equilibrium equations: the summation of forces in the x direction, the summation of forces in the y direction, and the sum of moments about a point, so we have to be selective about our cuts. The sign convention is opposite that of the method of joints, so we're assuming the forces in each member are tensile. Let's reconsider the truss from the example in the previous lecture. We want to determine the forces existing within each member using the method of sections. We'll start with a global free body diagram and employ equilibrium equations. We won't spend much time on this since we've seen this global free body diagram before, but we'll go over the values. RCX is equal to 0 newtons, REY is equal to 10,000 newtons, and RCY is equal to negative 7,000 newtons. Now we'll cut members AB and AD and draw the forces FAB and FAD acting away from the cut plane. First, we'll take the summation of forces in the y direction. We'd have FAD times the sine of the angle between members AB and AD, which we found to be 8 meters per 10 meters, since the hypotenuse of a 6-8 right triangle is 10, or 0.8, plus the applied load of 2,000 newtons. We find FAD to be equal to negative 2,500 newtons. A negative sign here indicates that the member is under compression. Note in the method of sections video, we found FAD equal to 2,500 newtons. Due to sign convention and Newton's third law, this member was found to be under compression. Now we'll take the summation of forces in the x direction, and we have FAB plus FAD times the cosine of the angle between members AB and AD equals 0. The cosine of our angle is simply 6 meters per 10 meters, or 0.6. We find FAB is equal to negative FAD times 0.6, which is equal to 1,500 newtons. The positive sign indicates the member is in tension. Note, in the method of sections video, we found FAB equal to negative 1,500 newtons. Due to the sign convention and Newton's third law, once again, this member was found to be in tension. We'll proceed through the system and cut members AB, BD, and DE. It's okay if we cut the same member twice. We can't have more than 3 unknowns at a time, so conceivably, we could cut 4 or 5 members if we knew 1 or 2 of the internal reactionary forces. Starting with the summation of forces in the y direction, we'd have FBD times sine theta, the angle between members DB and DE, which is 0.8, equal to the applied load of 2,000 newtons. Solving this gives FDB equal to 2,500 newtons. Then we can apply the summation of forces in the x direction. FDB times cosine theta, the angle between members DB and DE, plus FAB plus FDE is equal to 0. Recall cosine theta equals 0.6. We just solve for FDB and we have FAB, so FDE is equal to negative 3,000 newtons. The negative sign here indicates this member is under compression. Now we can move through and cut members BC, BE, and DE. Applying the summation of forces in the y direction, we have FBE times sine theta, which is 0.8, plus the sum of the applied loads, 3,000 newtons, is equal to 0. Applying the summation of forces in the y direction, we have FBE times sine theta, the angle between members BC and BE, which is 0.8, plus the sum of the applied loads, 3,000 newtons, is equal to 0. We find FBE to be equal to negative 3,750 newtons, and the negative sign indicates the member is under compression. With this value, we can apply the summation of forces in the x direction. We have FDE plus FBC plus FBE times cosine of theta, the angle between members BC and BE, which is 0.6. Recalling that we just solved for FBE and we have the value of FDE, we find FBC equal to 5,250 newtons. The positive sign here indicates the member is in tension. Now we can cut members BC and EC. In doing so, we recognize that we only have 1 unknown. Applying the summation of forces in the x direction, FBC plus FEC times cosine theta is equal to 0, and we find SEC to be equal to negative 8,750 newtons. The negative sign here indicates this member is under compression.